Hi, good afternoon. This is Mr. Cassidy, and today we're going to be covering a review of Chapter 3, Lesson 5, and graphing. We skipped Lesson 3, or Chapter 3, Lesson 4 last week, so this should help us, though, really understand the ideas in Lesson 5. Then we'll cover Lesson 4 a little later in this week. All right, let me go ahead and get this ready so you guys can see okay. Awesome, there we go. Okay, so, in our class, we covered a major idea that we've covered so far is slope. And by now, you know that slope stands for rise or the up or down change in a line over run. It's a ratio. A ratio sort of shows how much it rises for how much it runs. And we can use this information for a ton of different things. It's really a very big idea, literally, in our curriculum. So we first started with some graphs. I want to take a second to review. So what we always do is we start on the leftmost dot, that is a coordinate pair, going to the right. And what we want to do is we want to move on the grid lines. Move on grid. Okay, by doing that, that way we form a right angle and we find the rise over run. So I'll review with A. The leftmost point is here at 0, 3. And so I like to do my rise first. So I find whether it's up or down first. So I'm going to go on the grid because I want to get to this other coordinate on the side, 6, 0. And I want to use the grid lines. I want to go in two straight lines. So I'm going to go down first. And I'm going to count how many squares that is. That is 1, 2, 3 squares down. Since it's down, I'm going to do -3. If it was up, it would be positive. So if it helps, right, again, up is positive, down is negative. This was down 3. Then when I pause at 0, I'm going to go over 1, 2, 3, 4, 5, 6. So the run is 6. Down 3 over 6. That is the ratio of this line. So I put down 3 over 6. The run is my denominator. And again, run, I always go left to right, so it's positive. Now I can simplify that fraction. Remember, the negative can now go in the front of the fraction and simplify it to 1 over 2. That's the slope of this line. Okay, for B, go ahead and try it yourself. What do you find is the slope? Here's a coordinate pair here, and here's a coordinate pair here. Okay, you should have found that this line is rising 2 units and running 1. So our rise over run is 2 over 1. Okay, how about C? Here's one pair of coordinates that works, and you could just use this one as the other. Okay, you should have found that the rise over run here is up 1, 2, 3, 4, 5, 6, right to there. And the run is 1, 2, 3, so we make a fraction here. Rises 6 over 3 is equal to 2 over 1, or just 2. Same slope as that other line. These are the exact same steepness, even if it doesn't look like it, because they rise and run the same amount. The same fraction is used in both. Okay, what's the rise over run of D? Well, you might recall Slope Dude. What would he say? He would probably say this is zero fun because it has zero rise. We can't go up at all. Over the run is infinite, so it's 0 over, well, infinite. Well, 0 over anything is 0, so the slope is 0. Our next idea was slope from a table. And again, y, the change in y is our rise. Change in y, which is what we were just finding on the graph. We were going up or down on the y-axis, or the y-grid line, and then going over on the x. Change in x is the denominator. So we do that on the outside on my example here. I'd find from 1 to 4 how much is being added or subtracted. Looks like it's adding 3 here. And then I go, that's going to be my numerator. Change in y is the numerator. For the denominator, I'm going to go, okay, that's adding 1. Change in denominator is plus 1. So 3 over 1 is my ratio, my slope of the example. Okay, go ahead and try A. Find the slope of this. You should have found that 0 jumped up by 4, and 0 to 1 jumped up by 1, so the ratio is 4 over 1, or just the whole number 4. I like to think of slope as a fraction. You'll see why later in the chapter, or in the lesson. Okay, how about B? Go and find the rise over run here. You should have chosen that the y was rising 5 when the run is running 2. So our fraction here is 5 over 2. Remember, y is rise. Both have that I sound in them to help us remember. All right, last one. Remember, f of x stands for y. Go and find the rise over run here. You should have found that the y went up 1 when the x went up 1. So the correct ratio is 1 over 1. All of these are positive examples. Now, a negative example would just mean that one of those, either the x or the y change, was negative. If both were, then the negative divided by a negative would be a positive. So that's where we roughly left off. Now, some classes got a little further than others, but our next idea is this. What do y equal mx plus b? What does that mean? So in order to understand that, I'm going to shift to a website here and review. I know some classes did this, but we're going to go ahead and use it as a quick introduction to the formula we have for a line, y equals mx plus b. I will provide this link so you can play with it yourself after you watch in the notes. So here I have a line. It's mx plus b, and what it has it doing is I have this slider where I can change the m. So watching as it changes, notice that as I move it forward here towards 0, it gets flatter and flatter. And then as it goes up, it increases. And if I go backwards again, I can sort of see it going less steep and less steep. And then again, as it gets towards -10, it gets more and more steep. Interesting. So whatever is m seems to be affecting the steepness. Well, how about b? What does b do then? So take a quick look. Here's my line. And with b, I'm going to go up and down. Let's see how that changes the line. Now I know what our brain does here. They might see this line as moving left to right, but I would encourage you to start thinking of this as moving the line up or down. So notice that b changes the y-intercept. Here I have b is 3, and it's putting a dot on the graph right here at 3, 0, 3. And when I move that down, notice that dot moves too. It moves to 0, 2. So wherever this b is the same as where the line begins on the y-axis. We call that part the y-intercept. Now I'll give this to you so you can play with it in the notes, but please do explore it. The better you understand that what m and b mean here, the better you're going to understand this entire chapter, and really a major idea in IM1. So we just figured out what they mean. Y and x always just mean our variables. X is our input, y is our output, and creates our pair of coordinates. Whatever we put in x does some math and gives us the output, the y value. But what does it mean when I have a number in front of x, like 1/2, and a number over here, +2? Well, each of these represent the letters M and B. 1/2 is falling in the M position. B is 2. So let's start by analyzing just the part B. Now you may recall from our graph, B is the y-intercept. You can find this note and some ideas about it on page 82 of your journal. B is our y-intercept, and what that means is we have a coordinate. If you look back at our graph here of an equation, when b was 5, notice the dot on the line is at 0, 5, because when x is 0, y is 5. So anytime we find the y-intercept, we actually can find a coordinate pair. X is going to be 0, because 0 times 1/2 plus 2 gives us the y value of 2. So the y-intercept for this equation is 0, 2. Notice we always get a coordinate pair. Notice that x is 0 when y is at this y-intercept, 2. So what would be the y-intercept of A? Well, what you're going to do is you're going to circle the b value with its sign, and then we turn that into a coordinate pair. So the b value here, or the y-intercept, is 0, -8. And that is a point we can graph. So what would be B, or what is the y-intercept on letter B? You should have come up with 0, -2 when we circle it with its sign. What's the y-intercept of C? You should have come up with 0, 4. That's the y-intercept when x is 0, y is 4, and all of those are the point at which this line, whatever line it is, will cross the y-axis. When x is 0, we get our y-intercept. And whatever line it is, it doesn't matter if it's negative, positive, it will cross the y-axis there. So how about M? What does M mean? Well, M stands for move to me. It tells us the slope of the line. Remember, slope, as we just discussed, is the rise over the run. And so when we find the M in an equation, for instance, in the first example here, we're looking for what is where M is in the equation. Here it's -3/5. Just like that. That is our slope. Okay, what's our slope in B? You should have chosen 3. Okay, and what's our slope in C? Please think carefully here. Okay. Our slope is actually, remember, there can be an invisible 1 in front of this x. So our slope is actually -1. All right. So what if we had to try some tougher ones, though? Well, remember, guys, these numbers are going to tell us that steepness of the line. Sorry, before I move on, I should explain. So after we found the y-intercept, we can sort of look at this line and imagine what it's going to look like. Like here in A, -8 means it's going to be down below the x-axis where it's beginning that y-intercept. And -3/5, well, that's a nice negative line. So we're going to get a negative line like this. Our goal is to sort of have a good understanding of how an equation becomes a picture on a graph. What if there are exceptions and challenges? So in our first exception, notice it's not quite an mx plus b format. Well, we can switch these around. This is +5. This is -2x. We just rewrite it as y equals -2x plus 5. And so then we would say, okay, what's our y-intercept? B is equal to 0, 5. And what's our slope? Our slope is -2. All right, go ahead and try it yourself. What is the B? What is the y-intercept on this problem? Okay, the y-intercept here is at 0, negative 12. Okay, here's another, what's the slope in this problem? Our slope is 7, or if you prefer, 7 over 1. Remember, this would mean the same thing as 7x minus 12. Here's another exception to the rule. What if something's missing? Well, if something's missing, it's 0. The only thing that we can miss is 0. Something missing would be a 0, is 0. So on the first example here, I could imagine, well, y equals x, well, it could be 1x. So what is the y-intercept? Well, mx plus b, but b is missing, so b is 0. The y-intercept must be 0, 0. Here, what's the slope? What's the m? The m is going to be 1. Slope is just 1, or 1 over 1. All right, next. What if something else is missing? Here I've got y equals 10, but I've got no mx. Mx is the important part, so I sort of have y equals, well, 0 is whatever is missing is 0, so 0x plus 10. And 10, so what is my y-intercept? Y-intercept is at 0, 10. And my slope is 0. Okay. All right. That line would probably be 0 fun to graph. How about you try it? Go ahead and try this one. What is the y-intercept of this line? We should have said that the y-intercept was at 0, negative 2. All right, and what is the slope of this line? The slope is 0. This would be the line y equals 0x minus 2, where the slope is 0, but minus 2 is the y-intercept. Okay, and how about this one? What's the y-intercept here? Well, here the y-intercept would be 0. 0, 0 would be the origin, because we could put a plus 0, and since that's missing, anything missing is 0. That means our y-intercept is at the origin. So what's the slope? Well, remember that trick. We could have a negative 1 in front of this. So that would mean that the slope is negative 1. Again, I like to think of slope as a fraction, negative 1 over 1. And we'll talk about why in just a second. And what if they look really weird? Well, back in chapter 1, we learned how to solve for a variable, isolating the y. And we're going to practice using that same skill here, because what we want is y equals mx plus b in order to solve these problems and easily find what the slope and the y-intercept are. I will say a problem like this was the most commonly missed on the test last year. It was a new test, I'd never given it before, and a ton of kids got it wrong. The question was just, what is the slope and the y-intercept? And what we're going to do here is we need to change this equation till it's y equals. So first I'm going to work outside in. I'm going to remove this x, it was positive, by subtracting x. I'm going to rewrite whatever's left. Negative 3y equals negative x minus 2. I'm going to start setting it up in mx plus b format. Then I'm going to divide by a negative 3, divide by a negative 3. And remember, we sort of learned that trick with fractions like this. Instead of leaving it as a fraction, let's divide each thing by negative 3. So we have a negative x, that's a negative 1x, divided by a negative 3 is a positive 1 over 3, and we can just put the x in front of it. Notice what we're getting here. Then we have negative 2 over negative 3, so that would be, again, I'm just sort of separating each of these division parts. Sort of separating out their fractions. Each one is its own. That would be a positive 2/3. So what's my y-intercept of this line? Well, it's 2/3. At 0, 2/3, that's where it will pass the y-axis. What's the slope of this line? It's 1/3. 1/3 is the slope. Okay, now it's your turn to try it. First, solve for y here. Okay, you should have subtracted 2x from both sides and gotten that y was equal to negative 2x plus 12, or maybe you wrote 12 minus 2x in your paper. Now what's the y-intercept? You should have gotten 0, 12. And what's the slope? You should have gotten negative 2. Now, here's why we've been practicing all that, is all of that practice helps us with graphing. Being able to name the y-intercept and name the slope of every line makes graphing much more simple than you would imagine. So previously, we did graphing by doing this big chart, and we did like an X and a Y, and we figured out what was in the middle, and we did input and output, and we graphed those dots to get the graph. Well, this is another method we can use to graph. M is for, well, we've got y equals mx plus b. M is for move. B is for begin. M is for move. That's going to tell us how to move to the next dot. B is going to help us begin the line. Let's practice just learning how to begin each line. So I've got the equation y equals 1/3 x plus 3. What's my y-intercept? The plus 3 here. I am going to begin on the y-axis. Like we learned, the y-intercept is at 0, 3. I'm going to plot that dot. 0, 3 is the y-intercept here. Okay, your turn to practice. What is the y-intercept? What is the graph of the first dot that you will place? You should have chosen that the y-intercept was positive 1, and then we begin in the middle at positive 1. 0, 1 is our y-intercept. Here, your turn to try it again. Here I have what if there is negatives. Where is your first dot going to go in the first graph? Well, B for begin is negative 3. I'm going to go on the y-axis to 0, negative 3 and graph that point. That's my first dot of that line. How about the next one? Where's the first point of this line? B for begin at negative 1. As you get better and better at this, it gets a lot faster. Okay, awesome. Now we have half the line. Honestly, all we need is 2 dots in order to graph a line. Let's see how to graph it now using the slope. We plotted the y-intercept. That's when x is 0. Now we're going to use the slope to get to the next dot. My m in the first line, how we move this line, is 1/3. So what's the slope? 1/3. I'm going to put arrows for rise over run. Remember at the beginning of the lesson we said rise was up or down? This is positive, so I'm going to go up. I'm going to add arrows here with the slope. Rise is up 1. Run is over 3. I'm going to use those directions to find the next dot. I go from this 3, and let's see if I can change colors briefly for your understanding. I'll change to green. I'm going to change from 3. I'm going to rise 1 and then go over 3. 1, 2, 3. I make sort of a little staircase. Where I end after rising 1 and running 3 is the next dot on this graph. And actually, this is true because if I put in the number 3 as input, I would do 3/3 plus 3. Well, that's 1 plus 3 is 4. I get the y value, the output here. What's nice about this is this staircase. So I'm going to go ahead and connect this here. That would be the graph of this line. This staircase here is incredibly useful because actually you can keep doing it. You can go rise up 1, run out 3 to the next dot. Up 1 over 3. We're graphing using the slope. Okay, so your turn to try. What's the slope of this line? You should have chosen 4/3 here. Okay, How do we write this with arrows? We should write, well, it's positive, so we're going to, oh, well, let make you figure it out. So there's our slope. M is 4/3. Is the 4 going to be up or down? Up. And 3 is always to the right. All right, so let's go ahead and find the next dot. You find it on your grid on the screen. What's the next coordinate that is on this line? Remember to begin with the beginning. We start from our y-intercept. I was going to try to change the color, but I can't. So I'm going to rise up 4. I'm going to go up from 1 unit, 2, 3, 4, and run forwards 3. 1, 2, 3. That's my next coordinate on this line. When we connect those dots, we get the nearest thing to having a straight line on my tablet. Okay, so let me reiterate. First, we find our beginning, our B, which is beginning in the middle on the y-axis. That gives us our first dot. Then we move to the next dot, going up or down and to the right. So what if we have something like this? Okay, we already did our beginning dot. We began at -3. Well, notice it's a nice negative slope, -1/4. So I'm going to put the negative with the numerator. It's easiest to just always put negative with the numerator. And let's turn that into rise over run. Negative always means down, so down 1, to the right 4, right 4. Let's graph that. So I'm at my beginning dot, and I go down 1, and I go to the right 4. 1, 2, 3, 4. There's the next dot on this line. And that's all we need to graph this line. Done. We didn't need to do a ton of math, we just have to count on the grid. That's what's nice about this. Once you learn how to do this well, you don't need to do a lot of math to solve the line and to get it on a graph, because you're just following a pattern here. You try the next one. We've already got our beginning dot. First, what's the slope of this line? You should have chosen -5/4. Okay? Now, what does our numerator mean is going to be the direction to the next dot? You should have chosen down 5, and our denominator, as always, is to the right, 4. Okay, now you find where is the next coordinate pair of this line. You should have gone from the beginning point down 1, 2, 3, 4, 5 to -6, and to the right 4. Now, I will tell you the most common mistake people make is because they're used to graphing coordinate pairs. Normally, we graph x first, then y. We go right and left, and then up or down. That's how we graph for a single dot. This is different. What we're doing is just finding the next dot on a line, which the line is going to move from a rise over run ratio. First go up or down, then just go to the right, and you will find the next dot based on the slope. So what about these weirder ones? Well, first, what's my y-intercept to this one? Well, the intercept is +0. Remember, anything missing is 0. So I'm going to graph that for you. Here's 0, 0. All right, now what's my slope? What's my m? Should have picked that m is 5. Okay, let's make that into a fraction. 5/1. Remember, any whole number can have a denominator of 1. Okay, now change that into rise over run. Where's your next point in this graph? Well, we would go up 5, 1, 2, 3, 4, 5, and over 1. There we go. We've brought ourselves to the next coordinate on this graph. It's a really steep line. Now, some of you are wondering, but couldn't I just plug in numbers for x and get the output and then graph those coordinate pairs? Yes, absolutely. That would be fine. Perfectly acceptable. This is just another method to graph that can be useful in math. Let's try our last one. First, what's our y-intercept here? Oh yeah, that's right. Anything missing is a 0, so our y-intercept is at 0. I'll graph that one for you. What's our slope of this line? Oh, that's right. We can multiply by 1. So m is -1. Change that into a fraction. Okay, -1/1. Keep the negative with the numerator. Change that into directions. Okay, that should be down 1 and to the right 1. The denominator is always to the right. I'm going to go down 1 and to the right 1. My next coordinate is at 1, -1. Now notice you can keep doing that pattern to find the next dot. I'm just doing sort of a staircase, hovering my pencil over, and I'm going sort of down to each next dot. And once you see the pattern, you could also go backwards with the same pattern if you're comfortable with it, to keep that linear line going all the way through the graph. And that's how we graph the line. We have one final point here about x and y-intercept. So take notes on this, please. The y-intercept, remember, is where the line crosses the y-axis, where the line intercepts, crosses the y-axis. And so what that means is, remember, the y-axis is right above here. It's where x is 0 is the y-axis. So the x value is always 0 at a y-intercept. So x is 0 at the y-intercept. And then whatever number where it crosses, where your line crosses, that's the y-intercept. We could just put b here, because whatever b is, whether it's positive or negative, will be the y-intercept. On this graph, it's at 0, 3. So 0, 3 would be an example of y-intercept. How about x-intercept then? Well, based on that understanding, I mean, it's pretty apparent. That's going to be where the line crosses the x-axis. And so what that means is sort of the opposite. So here's an example of my x-intercept. It's right here where it's crossing the x-axis. X value is 4, and that's when y, the up or down, is 0. 4, 0 would be an example of that. And so we always have the y value. The y part of the coordinate pair is 0 on the x-intercept. Now this would be your quick note, but I've got a helpful way for you to remember it. Pause to take a note. Y-intercept and x-intercept are now part of our vocab, and we want to just remember it's where they cross that axis. X-intercept, x is where it crosses. Y-intercept, y is where it crosses. But here's how I always remember it, because I'm a big fan of tricks to help our brains remember things well. Oh, before we do that, the memory trick, let's just practice. First, what's the y-intercept on this graph? I like to start with y. You should have chosen 0, -2. If you didn't, go back to the last slide and write it down really quick. What's the x-intercept here? Well, you should have chosen 2, 0. All right, how about the second one? What's the y-intercept of the second graph? You should have chosen 0, -1. Okay, what's the x-intercept of the second graph? You should have chosen -2, 0. And here's my method for remembering. So to keep them straight, imagine you've got a football game, and we've got the X's throw the ball, but the Y's interception, and he runs with the ball all the way forward and crosses the y-axis right there, going all the way for the touchdown. Okay. Well, in the very next play, well, I don't know enough about football to know whether or not, but maybe it's the next play. The Y's throw the ball and the X's intercept it, but they do that boring thing where they just go out of bounds on the x-axis. Here's our x-axis. But you know what happens every time the other team intercepts? When the Y's throw the ball, or the X's throw the ball and the Y's intercept, you know how the X's feel? Like zeros. When the other team intercepts the ball, when you're at the y-intercepts, the X's feel like zeros. And the reason why is because if you graph it, remember, X is 0 whenever you get the y-intercept. And the same thing is true for the other team. When the Y's threw the ball and the X's intercept it and ran out of bounds and they crossed the x-axis, how did the Y's feel? Like zeros. Which is why when we get to the x-intercept, the y value is always 0. Well, I hope that helps you remember it. My poor excuse for football knowledge. And I thank your minds and your hearts. And I hope you guys have a wonderful afternoon.